thank you all for, thank Peter for inviting me. Pay attention at the back, please.
Sorry.
My name is Martin Greenhow. I'm a lecturer in mathematics at Brunel University, and I've come up today partly for this, but also partly to attend a meeting at 2 o'clock in your city campus, where I'm working with the economics people. And this is not a coincidence. If you talk to economists, biologists, psychologists, certainly engineers, they will all say our students are not what they used to be in terms of mathematical preparedness. Now, there's a lot of hoo-ha about this, and I could give a whole talk on that. But basically, there is a perception, certainly, that students need more practice and they need more feedback in sort of elementary mathematical skills. If you look at a question such as this one, it's about completing the square. And basically, a student who has got a B at A level would be able to do that question, but somebody with a D or an E would not be able to do that question, typically speaking. And Bill Cox at Aston University has done quite a lot of research on what is the likely preparation for various grades. We use these questions to actually diagnose the students when they come to us. This is perhaps not what they want to do when they first come to university. They want to have a nice time in Freshers' Week. And you know, the geographers take them off on a field trip down the pub. And we give them a lovely maths test instead. But we feel that it is worth it because the students are quite keen then, but we haven't given them any problem sheets. And this gives them something to get on with. They once knew how to do this, like in June, or May or June when they actually did the A-level, and they've forgotten it over the summer. So they think, yeah, I'm okay at maths, you know, and then they find, oh, bloody hell, I can't actually do this after all. And so it does encourage them to go and look at their books, their notes again, and hit the ground running when we start giving them lectures. Okay, this is a question on completing the square. It's actually what I call a question style. If I re-realize this question, you'll see that different things happen. Now the coefficients change, and also the variable, it was t, now it's y, and you can do things like this. This is a polynomial in z, etc. Now, just a little bit about the technology behind this type of question. This is written in JavaScript, and I'm using Perception 3 to author this in. And what we do is we write some code, some JavaScript code, which chooses the parameters at runtime. So various parameters are chosen, including an index for the letter that we're going to display, Z in this case. And then all the equations are rendered using MathML. So basically, you have a problem immediately. How do you display a polynomial? You don't have control of the parameters to the extent that you would if you hardwired a question. And so there's two types of functions behind this one. One that actually does mathematics for you, and that's not used in this case, but I mean those sorts of functions, but one which displays mathematics. And there's a function display polynomial which inhibits the display of things like 3x squared plus 0x plus minus 7. We don't write that, we just write 3x squared minus 7. And so cleaning up the mathematics is a fairly major task unless you do it offline, outside the questions. And of course those functions, all of these external functions, you'll see a lot of them for things like matrices, for example. They are available to all the questions, any question that cares to call them. And obviously there's another one here, display low fraction here. This is cancelled fractions. Regardless of what the parameters are, it will come up. It won't display 12 over 16, it will display 3 over 4, for example. So there's quite a lot of work involved in getting the mathematics looking as it should be. And that's important because the right answer, if it doesn't look right, is going to be avoided by students. Okay, let's have a look at the feedback. I'm hoping to get this wrong. Oh, I did get it wrong. Okay, so now we've got a general theory. This is the bit that they all like to ignore. We don't do general theory. And here's this example with the numbers. And here I've deliberately not displayed it as it should be written, so that they can track, well, A is minus 7, B is minus 6, C is 0. And they can track it exactly through and mimic what's happening over here and in the end they get the correct answer displayed at the bottom. This is possible because we're using MathML as the markup language, and Peter's an expert on that. MathML is about as powerful as LaTeX, and all of these functions are available to any web page or any web system. It's nothing to do with perception, and it's not even anything to do with CAA. This is a general web tool for displaying excuse me, for displaying mathematics on a web page, which is what you're looking at. One of the unexpected advantages of this is that you can customize it how you like. So if we go for 20, and then we'll have a different background color. Supposing a student wanted to do this, then next time the question is rendered, the whole look and feel of the question is different. And this goes some way, quite a long way, perhaps all that we can do even, for sender compliance. That is, making things accessible to partially sighted or dyslexic students. It's very difficult to go further than that. We can cope with perhaps, the vast majority of disabled students, dyslexia and partial sight, perhaps. But when we get beyond that, total blindness, it becomes incredibly difficult to make mathematics accessible. If I were to read that question to you without displaying it, you would have a hard job writing it down, even though you're trained mathematicians. So mathematics is incredibly difficult to put over in a user-friendly way, and this is our concession to that. It's an unexpected spin-off of being able to do things in MathML, and nothing you see today is a hardwired graphic, apart from this logo up here, which is the credits. We've already seen that one. There's print this screen as well. The students can print stuff off if they want. Okay, that's enough about completing the square. Here's one about economics. Now, when I set up that colour scheme, and I can change it if you're not happy, I will change it probably. But it looks different on my screen here. You've got a green, haven't you? So red-green deficiency, probably not. Yeah, right, okay, we'll change it to something else. Let's go for something like this. I'm hoping that this will be adequate for the camera. Yeah. So, basically now we've got a question which is about economics, and there's real currency in this now, so people start to pay attention because money's involved. And we've got here average cost in pounds down here. This is one of the things I hate about economics. Are there any economics people here? They use AC for one variable. Mathematicians would regard that as two variables multiplied together. No wonder students have a hard time with mathematics and economics, especially if they've got A-level maths. They're making it hard. Okay, as you can imagine, all of these numbers are randomized. An architect wants to minimize the cost per floor of a university economics department, and these are pounds. If we change that now, we've got an office block, still pounds, and now we've got euro. So some sort of spurious feel of being international. Probably there'll be yen and dollars here if I go on long enough. I seem to be stuck in. Oh, there's some dollars. Okay. So basically we've got a combination of random parameters in the question wording. And of course the question has nothing to do with what type of building. Mathematics is just mathematics. But it sort of encourages the student to think that this could be useful to them. And this is a numerical input question. So if I put in, well, students being what they are, they will put in their favourite swear word here, which I won't type in, but you can imagine what they hear, that will be recorded to the answer files. Well, if I put in something that isn't a number, then it's going to give them an error message saying, this is not right, it's invalid input. It must have a number here. And doing some post-checking is very important with mathematics, because if you say put it into 3 decimal places, and they put it into 6 decimal places, you really don't want to mark them wrong if they've done a lot of work and it's an integral. Unless the question is about significant figures and decimal places. But if it isn't, you've got to forgive them. Probably with a warning, saying, we're very nice people, you seem to have got the answer right, I'm going to give it to the correct number of decimal places for you. So you overwrite their answer, but only if they're correct. And you have complete control over what happens there. And here's the feedback, etc. So we come up with the optimum number of floors is 11.40 something something something, which of course is ridiculous. Now, is that 11 floors, because you can't build 0.4 of a floor, or 12 floors? Actually, you can't round. here because it's not a linear function. You have to work out both and take the minimum of it, which is what this explains down here. Very occasionally, you get that the question is ambiguous because the number of floors, 11 floors and 12 floors, it comes out to be the same average cost. You could imagine that happening because the function goes like that. Now, the way that question's done, and all the questions are done like this, is to reverse engineer them. You don't come up with the average costs, etc. You come up with the answer. I would like the number of floors of the building to be between 5 and 30. We don't have office blocks 1 floor high. We certainly don't have them 300 floors high. And if the students came up with that answer, and it was mathematically correct, they'd be very loath to put it in, wouldn't they? It's just ridiculous. So you have to reverse engineer the question, very often starting with the answer that you want. And of course, anybody who's set a partial fractions question for an exam will know all about this. A is always a third, B is a half, C is a seventh if you're feeling mean, otherwise a fifth, or plus or minus those. You know what nice numbers you're going to get there, and then you multiply the fraction up, you say, here's a partial thing, go and partial fractionize it. So reverse engineering is definitely something that we should be doing here. Now, here's a question. I showed this to the economics department, and they all said, oh, bloody hell, we can't do this. Oh, that's being recorded, right? Deleted expletive, right? We won't give this question to our students. It's the same question, but now I'm saying something about if the ground cost and the quadratic cost, building higher buildings goes up not linearly but quadratically as an approximation, because you've got to have bigger foundations, bigger cranes, construction becomes more difficult with very tall buildings. So G is the ground cost, Q is the quadratic cost, and the fixed cost per floor remains constant, then the total cost stays the same. Is that true or false or undecidable? And there's other statements here. And what happens is that this question is randomized by saying, give me the first part of a statement and match it with some arbitrary endings. So there's maybe 10 or 12 first bits, 10 or 12 second bits, and you put them together. Behind this, to do the marking, there's a matrix which says everything is F unless you've overwritten some of the elements as true, or perhaps undecidable. I mean, if P is R over S, and R increases and S increases, you can't say what's happening to P. That would be undecidable. So U would be the right answer there. And so these true, false, undecidable things, I'm not asking them to do anything explicit. What I'm saying is, what does the mathematics mean? And so this is moving away from just calculation, more to interpretive questions. And I think I'm getting quite enthusiastic about these types of questions. So if, I won't ask you to read all that and put it in. I'm just going to put 3 of them in as true. It's no good me pointing here, is it? A random guesser here could do quite well. And this is the toned down version. The original version said a baboon could get half the marks here, and of course you know what the feedback's going to be. You have the score of an above average baboon if they get it all right, or a below average baboon if they get, and I thought this was hilarious, but they said, oh, you can't do that, right? That was my feedback. Okay, I got them all wrong, and I'm told, and you see, you really do, here, the top bit here, okay, there's nothing for it, we've got to do some algebra. This is much harder than doing numbers, because they've got to interpret what the meaning of these statements are. If G increases and Q increases, what can you say about N? Nothing. Yeah? That sort of thing. It's much more difficult to actually... Well, they've got to know much more about functions in general. Here's another one, which is... we've done quite a bit on statistics, but we haven't used these questions in anger, in stats. But here's a very simple question in stats, which... I showed this to the health science people, and they got very excited about this and started doing the questions, the professor of health studies at Brunel. What type of data is this? And there's another question, how can you display it? So you've got something, some data, can be displayed as a histogram, a box plot, a stem and leaf plot, or whatever. Yeah? And you put those together and you have a sort of matrix behind it. Okay, so if I put in T here, for example, then, I got that one right. Okay, you see why an average baboon here well, here's the below average baboon I am, right? But it does make students think about what is meant by cardinal data, for example, whatever. Yeah. Okay. Here's a question about partial fractions. And this question is a 4 numerical input question. But the sexy thing about this question is I'm asking them what are the values of A, D, H and F. So we've got these positions here. Okay? Now if I re-realize the question, then now we've got completely different spaces here. And so this is a positional numerical input question. It chooses which of these it wants to display and which 4 are going to be knocked out and overwritten by symbols. And then, of course, we know what they all are when we start the question. It's all reverse engineered. You do have to worry a little bit. If this one were knocked out as well, this question would be ambiguous. And you'd have to say, cancelling any common factors and making D negative if necessary, or something like that. It's got to be ambiguous. But you need some post-checking afterwards to make sure that students, had done that and weren't simply marking them wrong if they hadn't, if they got the right answer. And there's some feedback behind here. So this is the level of feedback. Now, when the students, this was a final year project student wrote this question, and when students started writing this sort of level of feedback, I thought the users, the first years, are not going to read this. They're just going to scroll down to the bottom, click submit, and hopefully get the marks and so forth. And I was actually wrong. Completely wrong. This is where the students spend all their time. And I thought, well, yeah, how naive am I? I think I lecture quite well. You may think the same. And that once students come out of our lectures, they're fully formed, being able to do differentiation by, parametric differentiation, or whatever we've just been teaching them. In actual fact, they come out knowing nothing, almost. And what they do is they put in 2, 2, 2, 2, 2, something, and they read all this feedback. So this is not an assessment engine, it's a learning resource. And much to our surprise, had I thought about it, you never do you? Until you know what's happening on the ground. But students are using this very much as a learning resource. They'll go and they'll study all this, they'll write it down, they'll print it out, and then a couple of days later, when they're feeling more confident, they'll go and do the test for real. Okay? So, writing lots of feedback is not a bad thing. What we might do is have buttons saying want to know more and pop-up windows if they don't want to see all this. But our experience has been that they do want to see it all. Okay, what I'm going to do now is show you some linear algebra questions. Now, what I'm doing here is changing the... You remember I said that there were functions that lived behind the questions and were pulled in when needed? Well, I've just turned on all the linear algebra functions now. And if I realize this question, it's about eigenvalues. And, okay. Right. Find the eigenvalues of the following matrix. Okay, so what we've got here is a display issue. How do you display this in MathML? It's not a graphic you're looking at. If we re-realize it, we're going to get different power, for example. And if we put in something here, then we'll see the feedback. And when it comes up. Okay, so a to the 4 is that. Now that's of course the wrong way of doing it. You should work out what the eigenvalues of the matrix are and then raise them to the power 4, as any person would have told you in lectures had you been listening. Yeah? So again, this is the sort of thing they need for a learning resource. These questions can get awesome. I'll show you one. If we go to the matrices, let's see, multiplication. Okay. There are about 1,600 question styles or so, at the last count, behind these questions. And here we've got a matrix multiplication. And it looks a bit odd because I've got a large font size turned on. Had we got the default size turned on, it would have all been in the same line. But here's a matrix multiplication, and I'm asking for two values, x and y. If we realise this again, then we're going to get two different matrices. Not only are they different elements, they're all single digits, but they're different shape, these matrices as well. They're two conformal matrices between 3 and 7 rows each. And what we're knocking out are the positions of x and y. Now, of course, students can check some of these answers because the product matrix really is the product of those two matrices, and then two elements are overwritten. Okay, so they can check their algorithm here. Now, this is distinctly different from asking this in an exam. Here's a blank sheet of paper, go and do it. So you have to be extremely careful and, reflective on what information you are providing to the students. Because if you give them this and they get this answer right, it doesn't mean they can do this faced with a blank sheet of paper. They might be able to, they might not. What I do say, though, is that if they can't do this, then they're stuffed. This is necessary, but it's not sufficient. It's not all we aspire for them to be able to do. And obviously things like proof, very difficult to test objectively. So your homework for tonight, how many question realizations are there here? The elements range between -9 and +9, 0 is not included, and 3 to 7 rows columns in each, and x and y are knocked out. I haven't worked it out. I think there's about 10 to the 20 questions here. The amount of randomization is awesome, which means students can't tell each other the answers, but they'll find other ways to cheat, won't they? They'll fire up Mathematica or Derive or MATLAB or something on the side. It's quite possible for them to do that. Okay. Right. Just to sort of finish off, I'm going to turn on something else now, which is SVG. And I'll probably leave the linear algebra stuff turned on. These functions are just includes here. So this is just including the linear algebra functionality and the SVG. SVG stands for Scalable Vector Graphics. And just as the mathematics that you've been looking at has been interpreted plain text, rather like tech, and MathML is about as powerful as tech, if you get serious and go to the websites and don't use an interface and write it natively, MathML is an incredibly powerful and rich language. SVG is also very powerful and rich, okay, for drawing diagrams. And here we've got a load of names, and these are weights of children, and they're randomly chosen from a database. And when you see a name, I haven't typed that in. I was put up to this by my daughter doing A-level maths, and she said, if you're reading a book or answering a question and you want to know whether it's right, just look at the question wording. Girls get maths right, boys get it wrong. So political correctness here. So I thought, right, I'll fix that. So sex is a, flag 1 or 2. And then I thought, well, let's do this properly. So I looked on the census for 16 to 25-year-olds in Britain, and this is an ethnically balanced set of names, recognisably foreign names, with a few extras. Ingrid's my wife, for example, so she had to go in. So this is about packing. And if I look at the feedback, the thing that I want you to look at is this. This is a pictorial representation. It's a schematic, but the lengths of those lines are really proportional to the weights of those children. Okay, so for example, Jack is pretty overweight maybe compared to Georgia, that sort of thing. And these red bits are the spare capacities of the groups there that haven't, this is the maximum weight for a tug of war team. So it's about close packing. SVG can also be used in other areas, linear programming. Wherever you naturally want to draw on the blackboard, that's what we should be doing, at least with the feedback. And here we've got an SVG thing, which is, I'm asking about the yellow region. Which is the inequality? Now, those two lines, that we've been pointing here, those two straight lines actually correspond to the inequalities that you can't see. What I will do, so you can actually see the question, is the whole thing, is to reset that Okay, now you see, well, you may not be able to see the inequalities. There are 4 inequalities there, but the diagram has also changed size. It's no good having small diagrams if the student has got a huge font size turned on because they're partially sighted. And again, you can play the same trick. You can calculate the canvas size and scale your graphs in SVG accordingly. So again, this is quite an important feature to be able to access for disabled students to be able to access this. Okay, so we're asking, and of course the line thickness also increases. I've got a very small font size turned on here. So that's the sort of thing you can do. I'll put something on like this. Okay, so I've written a cookie. The students would write a cookie. Depending on your system, that will last for up to a year. At Brunel, they reset them every night for some irritating reason. That's the computer centre. But on your own machine, this would last indefinitely. And we've got something about what is the yellow region here. If we re-realise that, the yellow region is going to change, I believe. Or perhaps it isn't. No? Perhaps it isn't. Perhaps the wording changes. No, this is one. This is a clone where the yellow region is always that one. There are 4 other clones of this, or 3 other clones, the other 3 feasible regions, or possible regions for this. So you can obviously clone things and recycle questions. Okay. Here's an actual, so that was just about feasible regions. Probably the most difficult part of linear programming is getting students to be looking in the right region and understanding these strange inequalities. Okay, we've got a zoo keeps hippos and yaks, and there's bedding and feed for these animals. If we change that now, British Antarctic tobacco, a thinly veiled British American, right? Mother's Day gift, and it says somewhere for children that don't like their mothers or parents very much if they're buying them tobacco. A bit of moralism coming in there. And here we've got a Mother's Day gift. Oh, that one had. Here we've got some share dealing. Cigarettes again. Electronics company. This is all the same question. These are just different scenarios of the algebraically the same question. So there's no point in having more. You just give us a scenario number, and if you say, if it's number 5, talk about health authorities with drugs and hospitalisation, etc. Of course, the numbers have to be realistic. That's the other thing. So you do have to worry about that a bit. And here's the complete solution to that. And basically, that's the optimal point up there. So we shouldn't bother with drug B. We should do drug A only, in this case. Now, the question is coded up so that it can be any one of those 3 points. That one, or this one. About a third of the time each. And again, you have to reverse engineer that. Otherwise, students will say, oh, it's always the top right one, or it's always the one, diagonally opposite the origin, or something like that. Okay, I didn't say much about the wrong answers. Any fool can write a question and get the right answer, so I tell my students. That's not strictly true, but generally speaking, getting the wrong answers is a real art in itself. And the way we've done that is we've coded up MAL rules, which are logical but incorrect ways of doing a derivative. So, for example, if you're saying, what's the second derivative of a parametric function, you might give a MAL rule as y double dot over x double dot. It's a feasible thing for students to do. They might well do that. It's wrong, but you can see where they would go. And then if they choose that option, the consequences of that option, you can say, aha, you've probably done this. So you're telling students not just that they're wrong, but why they're wrong, which is our best guess at that. And students are saying that we've generally got it right. In fact, sometimes you get sort of surprised, how did it know? That's exactly what I did do. With the numerical input questions, we've tended to move away from them to what are called responsive numerical input questions, where we have obviously the right answer, and then we have MAL rules giving the wrong answers. So, for example, supposing the right answer is 5 to a differentiation, we would put in -5. And the feedback would be, oh, you've forgotten that the derivative of cos is minus sine, or whatever it is. And you can have as many distractors behind the scenes. Since they're not on the screen, you can have as many distractors as you can think of, programmed up, and it just checks them. Is it right? Is it the next one? Is it the next? And then it drops through and says, we don't know what you're doing here. Are you guessing? Funny, how did it know? You know, I was guessing. Okay, let me just show you another. Okay, now this is something we're doing just recently, which is it's now firing up linear algebra, SVG, and some graph theory stuff. And here we've got an incidence matrix and its graph. Okay, and that's generated at runtime. And if we re-realize that question, we're going to get a different graph according to the incidence matrix. And the question is about what are the edge sets. Very difficult actually to input the correct answer, because you have to put them in alphabetical order, separated by commas, all the rest of it. And so again, some post-checking is going to be necessary. All we've done is check whether they've got the right string length here. But putting in strings is very difficult for students. Of course, you can change uppercase to lowercase for them, etc. But just getting the right string length is going to be a major problem. And this has been a problem with more advanced questions. They've had to be very heavily scaffolded for the students to be able to input their answer to the product of two matrices. You've got to give them the resultant matrix, say fill in these elements, so they know immediately it's a 2 by 3 matrix that they're after, because that's the number of boxes. This again is very different to what we do on paper. So, you know, although I'm fairly upbeat about CAA, there are limitations. Okay.
It's got into that room there.
I better turn off the graph there. See, this is the penalty for having the extra functions turned on. There's the response time. Okay, SVG here again. This is all coded up. That angle really is 58 degrees. The other one's 63 degrees. 59, 60. These are the correct angles. Now, of course, there are some downsides to this. If you give them an accurate diagram, you say, what's the third side of this triangle? They might measure the first one with a ruler against the screen, measure the second one and do a proportionality calculation. And there would be nothing to stop them doing that, unless you actually make the diagram slightly wrong, or ask them to put it into 5 significant figures or something like that, yeah? You can force them to use the cosine rule in that case. But you do have to think about these things. And I'm sure I haven't thought of everything that students are going to do. No way. That's where you need to trial them. Okay. I'll just finish off with a couple that we've just been sort of doing, just to give you some ideas of... I will show that one as well. Okay. You might have seen some numbers flash up before that rendered. That's the SVG code. Okay, so it's plain text code. And here's a diagram. This is a diagram, it's not a graph. It's just a collection of lines. And here we've got... you'll notice that these input boxes are also resizing now. It's something that we're going to do with the whole database. It's no good having somebody who can't move the mouse properly having to select a very small part of the screen. And there's the sort of feedback. And again, it goes on and on and on. And I think next week, when these are used in anger, students will spend most of their time studying this. Okay, finally, yes. Right. So we're asking, now this of course is second year mathematics, isn't it? Well, it is a Brunel, second year engineering, that sort of thing. And so, again, we're giving them a lot of information here. Now, if we look at that question, there's nothing particularly obvious about this that's going to happen. It's this function, and then we've got some periodicity, so the function is not obviously symmetric or anti-symmetric. You do have to worry about that, because they might be able to ignore 2 of the things based on an argument like the value at x equals 0, or the asymptotic behavior, or the symmetry of the function. And, you know, you have to take a judgment on that. You might say, well, good luck to them. If they're clever enough to spot that, then fine. And that is a skill, but it's not the one you think you're testing. That's the problem. So interpreting the answer files could be difficult. Okay, if we go for this one, then what we're getting here is some feedback again. It's actually pretty difficult, soul destroying. I spent days checking this. This was written by my PhD student. And basically that's what it looks like. The dotted line is the sine function, well, part of the sine function, and the Fourier series, summations, partial sums of those other lines. So you can give quite a lot of feedback here. So the students would read that, and then they would look at this again a couple of days later, and they would say, okay, now the right answer looked a bit like this last time. And if they do it enough times, they'll be able to match the pattern. And that's something that the buggers have been doing with the Laplace transforms questions. Some of them, wonderful people they are really trying to do the question. Others do the test 10 times, figure out what patterns are behind these options, and then they can do 10 Laplace transform questions in 5 minutes. I can't do that. I'm sure they can't do that. So they're not actually doing the questions. And that's really a downer. I've discovered that in the last 2 weeks, and I'm profoundly depressed by it. So what we're going to do is say you've got to have maximum 5 attempts. Anything you do after that will be ignored. And you do have to allow some attempts because they're going to crash the system sometimes, etc. And you want them to read the feedback and benefit, but you don't want them to start matching patterns. You could get around that by having more questions, but these questions are pretty onerous at this level to edit, to actually generate. So we're going to do it for this year as having 5 is your maximum, and then anything you do beyond that is fine. A better way of doing it might be to engineer the syllabus so that you say to them, the way this module is set up, you get whatever mark you get from the CAA, but you've got to pass the exam in its own right, genuinely, at the end. An unseen written exam. So if they do cheat, then they can't pass the exam. Or if they cheat and not learn very much, then they will still fail the module. So we're really torn here between wanting to develop a learning resource and helping the students, and putting in barriers to stop them abusing the system and short-circuiting in some way. And that's probably as good a place as any to stop on a very negative note. But I think that where it really comes into its own is in the first year, particularly the transition from school to university, and in the sort of more methodsy things in the second year, such as this. Okay, so that's a sort of what I have to say. Any questions? Yes?
Your example of the problem with the multiplication of the matrices made me think, well, couldn't you first of all give them a choice of what the dimensions of the resulting matrix was, and then put that up on the screen and get them to fill it in?
Yes.
But then that would involve an interactive thing you haven't shown yet. In other words, being able to modify within the question while it was still ongoing.
Yes, you would want to do that from the learning resource point of view. You would not want to do that from the assessment point of view.
Well, except they'd lose the mark if they got the wrong one.
Yes, you could do that, yes. Yeah. You need quite a lot of coding behind it. Now this is a database, and there's a restriction of 32,000 characters. Those Fourier series are coming close to that. So, there's a lot of code behind this. So yes, you can do that. What I would probably want to do more as an assessment to see where the students are at, diagnostic for example, is to give them a matrix and say, what are the dimensions of this matrix? What is C57 in this matrix? In other words, just notational things, and then build it up. So that at the end you're saying, okay, we know they can do a 2 by 2 matrix multiplication, they can do a 3 by 3, can they do an n by n now? Yeah? And so you're sort of leading them through in that way. In principle, yes, you could do it. Interpreting the answer files would be really quite nightmarish, I think. But I don't know. I mean, it's a good idea.
I've got a question. I'll just explain, I'm not coming from a mathematics background, I'm coming from a CAA background. So
oh, right, okay.
This particular, so I'm
even better.
Fascinated by what you've done. It's fantastic work and a huge amount of work. But I wasn't quite clear on how you're using the assessments. You're saying that it's formative but used as an assessment.
Yes, that's right. It is formative. The marks do count.
Right.
Because when you get that sinking feeling when students come up and say, this test, does it count?
Yeah.
And you know what they mean. Does it count towards the module? And if you say no, but it'll make you into a better person, they don't do it. At least some of them do, and those are the ones that don't really need to do it.
Right.
So yes, there is an element of compulsion. You don't have to give very many marks though. 5% for half a dozen tests is plenty. Because 5% to a weak student is a huge fillip. It's a big boost, and they then know that I've only got to get 35% on the exam. A very strong student knows they're going to get 70% on the exam. Why bother with this? They probably do it. Sometimes lose interest. But that's fine if they can do the exam. So you have to drive them a little bit with marks.
Yeah, so within that you allowed them multiple attempts at the...
Yes.
Where you just took the best score out of the...
Yeah, the best ever score always counts. Right. The reason for that is that, of course, they might settle down trying to improve their 78%, and somebody waltzes into the room and says, right, you'll all have to leave, I've got this room booked. So then they get 3% or something, so...
no, that's very refreshing, I like that. Right.
Yeah, they can always improve, they can never lose a good mark. Yeah.
There's a system that they use for teaching C++ and assessing it at Nottingham University called Cayley, I think it was. And I've actually seen students who were taught on that doing the assessment by cutting and pasting someone else's answers. There were two screens up and they were basically all cutting and pasting, just copying answers. Now there's nothing in what you described that would stop somebody from getting their friends to sit down and...
No, aliasing is a problem. If you're serious about that, you have to invigilate the tests. But that can be done somewhat informally. And I quite like to be in the room when my students are doing these tests, because it's you and them against it. You're literally and metaphorically alongside them, trying to solve this problem that it's put up. And so you can do some very effective teaching. Yeah? And you say, okay, what do you think? No, I wouldn't do that if I were you. And then you walk away, that sort of thing. You've given them a bit of a clue. So as far as effective teaching is concerned, that's a very good way of doing it. But yes, there are all sorts of ways of cheating a system like this. Firing up MATLAB would do most of these questions, or Mathematica, or Derive, or whatever. You can get to the extent where you'd want to turn it off, on the university system, but then you don't know what the consequences of that are, because some electrical engineering lecturer will ring you up very irate and say, MATLAB isn't working and we understand it's your fault. Yeah? So, I don't know. I mean, I think it's certainly with the first year, you have to take a very relaxed view. The overall benefit for the most students exceeds the disadvantage of students cheating. When it comes to degree counting marks, then we have a real problem. Then you have to invigilate it under controlled conditions. You have to have, just like exams, know that it's them doing it. So, student ID card and all the rest of it. But then you lose the sort of informality of it, and, the chance to go in at sort of 12 o'clock on Friday night and do some after they've been to the pub or something, whatever students do.
But you could combine the two in a sense, because you're talking anyway about possibly having an exam at the end to make sure they're really doing it. So you could have all your first 4 tries, if you're restricting the tries, do on your own, wherever you like. But the one that will count will be in this room.
Absolutely, yes. That is true. It doesn't stop the pattern matching problem, though. They've spotted that it's always positive coefficients and all the terms are cos, then, you've got a problem on your hands by that stage. So, more questions would be the answer to that, I think.
And you were saying that maybe you wouldn't want to use MATLAB because it's cheating, but in a way, using MATLAB is what you do when you have a tricky question you want to solve it. So
that's right.
It depends what you...
Yeah, exactly, yes. We've actually written some questions in matrix multiplication where they were expected to use Excel to do it. So the questions were deliberately ridiculous sized matrices, 8 by 8 or something like that. Just to force them to be able to, because what you find is if you do 3 by 3, A-level students won't use, they know how to do it by hand, so they'll do it by hand. They won't use Excel, so that you haven't tested what you thought you were testing. So yes, I mean, I'm quite keen to even give them, as you mentioned, them to put in a bit of code and you to run it and see what it produces, and then give some feedback according to that. You know, your code doesn't compile or something like that. You could couple it in that way. Yeah, that's probably the next generation. I mean, I've talked about mathematics here. Most of what I've said has got nothing to do with maths. All the technology, I'm very keen for it to be exported to, you know, all of the engineering subjects, computer science, but things like biology, psychology, business and management, economics for that matter. A lot of this stuff is just really altering the question wording to some extent. And the technology sort of exists, yeah, mostly. Okay. Any other questions?
Are these questions available?
Yeah, yes, I'm glad you asked me that. Yes, it's all free. You can have this. And if you email me, I'll send you probably a CD, because the database is about 160 meg.
Right.
Although the actual code behind it is very short. So then you can lift out, certainly, I mean, if nothing else happens in 10 years' time, the functions that I've written might still be going. You know, CAA is changing, I don't need to tell you this, changing very rapidly. But these functions that enable web delivery of mathematics, those are some things which probably will survive, and the SVG will survive as well. Yeah.
You said you were using question mark 3. Are you
Yes.
thinking of moving to 4?
Yeah, good question. Yeah, they've completely snookered it in terms of question mark 4, although I'm discussing with them, because what they've done is they've had so much trouble with people rendering MathML that they do it for you and write a graphic of that question, that equation. So once you publish in question mark 4, you always get the same question. So I said, well, you've really pulled the rug from under my feet here. And they looked very sheepish and said, yes, we'll do something about that. And I think they are going to do something about it. So the next version of question mark 4 will have this randomization, which will run through the code rather than when you publish, running through the code, producing loads of graphics and storing them in some way and then pulling them straight in. The question mark 4 is incompatible with randoms. And they know that's a bad thing now. Yeah. But I can see why they did it. Because, you know, people had to have Java-enabled browsers and things like that to be able to run the questions, and that caused problems. Okay.
Thank you.
Right.
Thank you very much.